All right, let's look at this problem. Find the point on this curve that's closest to the origin and give an exact answer. So this curve, square root of x plus 4, that's the square root graph, but it shifted back 4 units. So this right here is negative 4, 0. We're trying to find the point that's closest to the origin. So I'm going to label a random point on this. I mean, obviously that purple point is not the closest one, but I want a function here that tells us the distance. So let's see, this point has coordinates x, and y coordinate is square root of x plus 4. This point down here, of course, has coordinate 0, 0. So the length of this thing, I'm going to call that L. The length of that line, we're trying to minimize L. So by the distance formula, L is the square root of x minus 0 squared, the difference in x values squared, plus the difference in y values squared. So if I work that out, this is just x squared, and the other one is, let's see, well, the radical and the square undo each other, so this one's just x plus 4. So that's the function that I want to minimize. However, it's easier to minimize the square of it. I'm going to call it s for square. The idea here is, if I were to draw in a square here, as this point moves around the graph, L is going to get bigger, and the area of that square is going to get bigger. So if I can find the point on the curve that makes this line the shortest, it's also going to be the point that makes the square the smallest. So that's why I can get away with minimizing the square instead of just the length. So, and also minimizing this is much preferable to minimizing that, because this thing, you just take the derivative, you get 2x plus 1, you set that equal to 0, so you get x is equal to negative, well, 2x is negative 1, so x is minus 1/2. And is that our answer? They said find the point, so we should probably give the x and y coordinate. X is square root of negative half, y is going to be, x is just negative 1/2, y is going to be square root of minus 1/2 plus 4. So it's going to be the square root of 3.5. Square root of 3.5. I'll just leave it like that. And that makes good sense. If you come back up here and graph that, x is minus 1/2, so let's see. That means somewhere right about here. And it makes good sense that this is going to be the point that's closest to the origin. And if you were to graph this out on Desmos and look at it real closely, you could see that. In fact, this is the one, if I were to draw the tangent line in here, it would make a right angle. All right, let's also look at this problem. A rectangle is bounded by the x and y axes and the graph of this line. So what are the width and height to maximize the area of this rectangle? So what this is saying is, we've got a bunch of rectangles we could look at. One side is going to be the axis, one side is going to be the other axis, and the corner is going to be up there. So I could draw a rectangle in like that, or I could draw one here. As long as that, basically as long as it has one corner on the origin and another corner over here, those are the rectangles we're looking at. We want to find the one that has the biggest area. Obviously, it's not going to be a long, skinny one or a skinny, tall one. It's going to be something in the middle. So let's work out the area of this rectangle. Now, if I pick this and I just call this x, then this point up here is going to have coordinates. X coordinate x, and y coordinate is going to be 6 minus 3/4 x. And the area of this thing is just going to be the width times the height. Well, the width is x, and the height is this length, which is 6 minus 3/4 x. So distribute that out, you get 6x minus 3/4 x squared. And that's what you want to set the derivative, take the derivative of and set equal to 0. So a prime is going to be, let's see, x minus 3/2 x. Or wait. That's not x. Derivative of 6x is 6 minus 3/2 x equals 0. So 6 equals 3/2 x. So x is, let's see, 2/3 of 6, so 4. So we should pick x equals 4 to maximize this rectangle. Now what did they ask? Let's make sure we answer the actual question. What width and height should it have to make its area a maximum? So x is the width. So the width should be 4. And if the width is 4, the height is going to be 6 minus 3/4 of 4. So the height will be 3. And they didn't ask this, but the maximum area we could get would be 12.